Hi guys, welcome to another video. The topic for today is ratio proportion. It's a very easy topic and very important. Okay, important because not only will the question directly come from this topic gets mixed with other topics very easily. Right? For example, we have done mixtures and allegations. So there, if you have done mixture and allegations, ratios come very easily gets mixed there. Plus we have data interpretation, right? Your graphs and tables questions. There also a lot of ratio proportion gets asked. Okay, so without further ado, let's get into it. Hi. So talking about ratio, what is a ratio, right? Or when do we use a ratio, or how do we use a ratio, right? So if you think about it, try to use it in a sentence, right? We say the ratio of boys to girls in the class is 5:7, right? So essentially, when you say that, right, what do you mean by that? Right? What we mean basically is that for every 5 boys, there are 7 girls. Now, this does not mean that there are 5 boys and 7 girls, correct? There can be more people in the class also, more students in the class also, right? What it just tells you is that for every 5 boys, there are 7 girls. So if there are 10 boys, there will be equivalent 14 girls, right? How do we represent this? So we simply write boys is to girls is 5:7. So this is how you represent any ratio. Okay, you just put an is to colon sign. B is to G is equal to 5:7. All right, 5:7 means 5 divided by 7. Okay, 5:7 simply means 5 is divided by 7. Okay, so basic point of ratio is that it's comparison of two terms. Okay, now question comes, what sort of terms can you compare? So we can always compare like terms. For example, number of people with number of people, number of boys with number of girls, weight with weight, right? Distance with distance, liter with liter, right? Point being that is why ratio does not have any unit. Okay, there is no meter kilometer written here. Why? Because you are comparing similar things. Okay, for that reason ratio doesn't have any unit of its own, because you are comparing similar things and you can compare anything, right, as long as they are same. So whenever there are two numbers or two things to be compared, we simply write the ratio as A is to B, which simply means A divided by B. Okay, and this is always written in simplest form. Okay, this is always written in simplest form. Okay, now what do I mean by simplest form? So integral form, okay, or integer numbers. Simplest form means in integer numbers. Okay, simplest form simply means that you use integer numbers. Okay, so which basically says you can't have decimals or you can't have fractions. Okay, say we have decimals, that A is to B is 3.5 is to 2.37. Okay, so that's not the right way to write ratios. Instead, what you do, you will write this as A is to B is 3.5 by 2.37. We have learned division of decimals recently in the previous class, right? Let's multiply this by 100 to remove the decimal. Okay, so we get A is to B as 350 by 237. Okay, we get A is to B as 350 by 237, right? Or A is to B is 350 is to 237. Okay, the point is that you don't write ratios in decimals. Similarly, you will not write ratios in fractions also. Okay, similarly, you will not write ratios in fractions as well. Say x is to y is given to me as 2 by 3 is to 4 by 5. Okay, again this is not acceptable. What do? We write x is to y as 2 by 3 divided by 4 by 5. Again we have done fraction division. What do? We flip and multiply. We get x is to y as 2 by 3 into 5 by 4. 2 and 4 cancels out. X is to y is 5 by 6. Again, the answer becomes x is to y is 5 is to 6. Okay. The point that I am trying to make here is that you always write ratios in integer form and simplest numbers. Alright. We don't want decimals. We don't want fractions. We want integer numbers. Now that we know that we understand how to make two number ratios. Okay. It's not necessary that I always compare only two things. Okay. Even though they are of similar kind, it's not necessary that I always compare only two things. See, I can compare the number of questions in quant section versus number of questions in verbal section versus number of question in DI section. Correct? I can compare similar things, but I can compare three similar things also. Right? Say for example, I have A is to B, so I compare A and B. I know A is to B is 2 is to 3. Okay. Similarly, I compare B and C. I know that is 4 is to 5. Okay, so A is to B is 2 is to 3, B is to C is 4 is to 5. Fine. Now, if I want to know what is A is to B is to C, what if I want to compare all three at once? Okay, how do I do that? So, the method is very simple and logical. Okay, no need to memorize anything. Understand what is happening. Okay, because if you do, then you can make 4 number, 5 number, however many number ratios you want. Alright, so see, we have A is to B as 2 is to 3. What does that tell you? That when A and B are compared, right, for every 2A there are 3 B's. Right. Similarly, below this, if I write B is to C is 4 is to 5. Okay, B is to C. Alright, B is to C is 4 is to 5. Okay. Now, in both the terms, B is the common, right? B is the common value. Okay. So, what do I try to do? I try to make B uniform. Okay. I need to standardize, right? I need to standardize it. What do I standardize? The thing that is common to both or thing that is common to all of them, right? The variable that is common to both is B. The value of B is 3 ones and 4 ones. Mathematically, how can I make them same? Correct. LCM. Correct. Absolutely correct. We do LCM. 3 and 4 LCM is 12. So we multiply this by 4, multiply this by 3. Okay. We multiply this by 4 and multiply this by 3. So what do we get? We get A is to B is 8 is to 12. Okay. We get B is to C is 12 is to 15. Now, since B is common, A is to B is to C is 8 is to 12 is to 15. The 12 and 12 combines into 1, B and B combines into 1. I get A is to B is to C is 8 is to 12 is to 15. I hope you understand this. Now, one point that we have to remember here, right? One point that we need to remember here is that see, when you multiply ratio, right? So see, ratio is the simplest form. A is to B, when I say 2 is to 3, that means A by B is 2 by 3. Correct? Now, when I multiply or divide a ratio, okay, when I multiply or divide a ratio by a common number, okay, when I multiply or divide a ratio by say x, the ratio does not change because numerator and denominator has been multiplied by the same number, which can simply cancel out, right? So when you multiply or divide a ratio by same number, right, the ratio does not change. So that is why when I multiply here by 4 and multiply this ratio by 3, the ratio hasn't changed. The values have changed, but the relationship has remained the same. Okay, this is also 8 is to 12 is same as 2 is to 3. 12 is to 15 is same as 4 is to 5. Okay, so when you multiply by a same number, the ratio does not change. Okay, alright. If you understand this, then let's try one question. Alright, I hope you have already solved this. So we know P is to Q, right? We know P is to Q is 7 is to 11. Okay, we know Q is to R is 5 is to 9, right? Again, what do we do? The common variable is Q. Try to make it same. 11 and 5, LCM is 55, right? Multiply by 11 and 5. So P is to Q is 35 is to 55. Q is to R is 55 is to 99. I can combine the two, right? Q and Q merges. P is to Q is to R is 35 is to 55 is to 99, right? All right. Moving on, right? If we understand this, if we understand the logic that see we are trying to make the common variable same, right? Let's look at other examples of this. Say I have A is to B is 2 is to 3 and A is to C, okay? And A is to C, right? Pardon my handwriting, right? Is 4 is to 5, okay? Now blindly don't multiply this by 4 and 3. See what is common? A is common, okay? What is common? The value A is common. So LCM of 2 and 4 is 4, multiply by 2, multiply by 1, okay? You get A is to B is 4 is to 6, sorry, right? And A is to C is 4 is to 5. Again, when you combine, the common variable remains. A is to B is to C is 4 is to 6 is to 5. Okay, so the point is, try and don't memorize, understand. The logic is we are trying to make the common variable same. That's all. All right. Now, if you do understand this, then we can continue this and make multiple number ratios, right? Like what's stopping us from stopping us at 3 variables only, right? We can add more variables. Okay, let's try this. Try this right now. Say C is to D is 6 is to 7. Okay, find A is to B is to C is to D. Find A is to B is to C is to D. Okay, solve for it right now. Or A is to B is to C is given to us as 4 is to 6 is to 5. Say A is to D is 5 is to 6. Okay, in this case find A is to B is to C is to D. Okay, what is A is to B is to C is to D? Right, try this right now. What do we do here? The variable C is common. Multiply by 6, multiply by 5, right? Multiply by 6, multiply by 5. 6 times 4, so A is 24. 6 times 6, B is 36. 6 times 5, C is 30. 5 times 6, C is again 30 only. 5 times 7, D is 35. So A is to B is to C is to D is 24 is to 36 is to 30 is to 35. Now here itself we ask, okay, that okay, tell us what is A is to D. So just take the values of A and D. A and D is 24 is to 35. Okay, if they ask what is B is to D, then take 36 and 35. Alright, the point is that if you understand the logic, you can continue this process for as many variables as you want. Alright, okay, let's solve this one. The common variable is A now. Don't see that okay, this 5 and 5 is same, so directly combine. The variable is different. 5 multiply by 5 multiply by 4, that's 20 is to 30 is to 25 is to 24. Okay, so I hope you understand that how do we form ratios. Okay, two number ratios are very simple. Simply divide them, simplify them, write them in the simplest form. That becomes your two number ratio. If you want to extend that to more than that, right, just see what variable is common, make it standardized by taking LCM, make the value same in both the places, so that you can merge those two ratios to make a 3 number or a 4 number or a 5 number ratio. Okay, now if we understand okay how to make ratios, it is equally important for us to understand how to solve them, right? How to solve ratios, right? It is equally important to understand how to solve ratios, right? Now if you, let's take a step back. Say we know A is to B 20, 30, 25, 24. Say we know that A is to B is to C is to D is 20, 30, 25, 24. Okay, we know this. Again, as I told you, this does not mean that A is 20, right? Similarly, this does not mean B is 30, C is 25 or D is 24. Okay, it does not necessarily mean that, right? And one more thing that we learned, right, just now was that if you multiply a ratio by a common number, the ratios does not change, right? The ratios do not change, right? So what I do, I multiply, okay, multiply this whole thing by x. Okay, I multiply this whole thing by x, right? Specifically the ratio side. Okay, specifically the ratio side. Okay, let me do that. Right. I'm multiplying this by x. All right, I'm multiplying this by x. All right, so what happens? We get A is to B is to C is to D as 20x, 30x, 25x and 24x, right? Now you can say that, okay, if A is 20x, then B is 30x, then C is 25x and D is 24 times x, where x is a common constant, right? Where x is a common constant. Okay, now what is the advantage of this method? Why are we doing this, right? Why are we not doing something else? See, the advantage of this method is all your 4 variables have been converted to single variable, right? All variables, right, have been converted into single variable. Okay, and now all you have to do is, depending on the question condition and the question word problem, just plug in value of A as 20x, B as 30x, C as 25x, D as 24x and solve and find x. If you get x, you will get all the values. Say for example, right, say for example we solve some question, right? They say that, okay, difference between C and A, right? Difference, say the question is difference between C and A is 20. Right. So now in place of C, I write 25x. Difference means minus. In place of A, I write, what is A? 20x. Okay, is equal to 20. 5x is 20. X is 4. Now that I know x is 4, A becomes 80, B is 120, C is 100, D is 96. Right. So the point is that if you know, like, you convert everything into a single variable, and then depending on the question word problem, right, you just, okay, you just solve the word problem, find x, you get x, you get all the values, right? Advantage is everything is in integer, so you don't have to, really get into fractions. Okay, now at the same time, right, at the same time, okay, I know some of us have already memorized, right, that, okay, if A is to B is to C is to D is this, A is 20 by total, that's 20 plus 30 plus 25 plus 24 into total, or x, right? So A is 20 out of 50 and 49, 99 x, right? That is another way to go. Okay, there is absolutely no problem with this. This is basically telling you the proportion of A. That, see, if A, B, C, D are 4 numbers in this ratio, right, then if I do the total of it, the total is 99. A takes 20 out of those 99 parts, right? A contributes, or the share of A is 20 out of those 99 parts, right? So A is 20 by 99 times x. Okay, A is 20 by 99 times x. Now here the meaning of x is the total. Okay, x is the total. So questions like these, when they say difference between C and A is this or something else, right? For such questions, this becomes lengthy and complicated. Okay, the only time we use this is if we know the total. Okay, the only time we use this method, there is nothing wrong with this method, but the only time we will use this method is if we know the total or if we are supposed to find the total. Okay, otherwise simply use x. Okay, otherwise simply use x. Okay, right, just use this. This is the simplest way to solve all ratio questions. All right. Okay, moving on to the next question. We have a is to b and we are supposed to find some ratio. Okay, we have a is to b is given to us as 4 by 7, which simply means a by b is 4 by 7. Okay, and we are asked 5a plus 3b is to 4a minus 2b. This is 5a plus 3b whole divided by 4a minus 2b. Okay, now we have learned recently, okay, if a and b are in the ratio 4 is to 7, you can simply write a as 4x, b as 7x, right? And you can substitute these values. Okay, if you want to solve the question, simply substitute these values. So 5 into 4x plus 3 times 7x, okay, by 4 into 4 times 4x minus 2 times 7x. Okay, that's 20 plus 21, 41x over 2x. 41 by 2, 41 is to 2. Okay, the point is that whenever ratios are given, okay, just close your eyes and simply assume a as 4x, b as 7x and solve. Okay, that's the fastest way to solve such questions, or not just such questions, any question which has ratio in it. Okay. Alright, if you understand this, right, this is all you need to know about ratios and problem solving. But see, we are going to study data interpretation later on, but there is one point that I would like to make, right, so that you understand why this topic is important and the use of ratios, especially in data interpretation. Okay, now say if x is to y is less than 1, okay, that is x by y is less than 1. Okay, think of it like mixture allegation. Okay, think of it like a mixture concept. All right, i have a mixture. Okay, I already have a mixture which is 40% in concentration. Okay, say there is a orange juice, right, which has 40% water in it. Okay, I have an orange juice which has 40% water in it. Okay, so water ratio is less than 1, water to total or water to orange ratio is less than 1. Okay, now in that, okay, in that juice, okay, which has 40% water, you add pure water. Okay, in that juice which has 40% water, you add pure water. Doesn't matter the quantity, a little bit, a lot, right, but you add pure water. Okay, what do you think will happen to the water percentage? The water percentage will increase, right? The water percentage increases. This is what our thinking is, right? So that is what happens here. That see, if the ratio x is to y is less than 1, that means x by y is less than 1. Now if I add k, right, if I add k to the numerator and the denominator, okay, if I add k to the numerator and denominator, okay, think of it like this. The original concentration was less than 1, 40%, 90%, 80%, 75%, right? What am I doing? Sort of adding pure k by k, which is 1 ratio. I'm adding close to 100% to it, right? So what will happen? The concentration will increase, right? That means this is greater than x by y, okay, which in turn will be greater than, right, which in turn will be greater than, right? If I remove, right, the same concept, the reverse of same concept is applicable now. Say 40% concentration, which is 40% water. If I evaporate water, what happens? The percentage of water decreases, right? The percentage of water in your mixture decreases, right? So if you have x by y, which is a ratio which is less than 1, it is less than x plus k by y plus k, and similarly greater than x minus k by y minus k. Okay, now question comes, okay, we understand this, where does it come in handy? So in data interpretation, they ask us to compare ratios, right? They will ask for which year was the profit to revenue ratio highest, or import to export ratio highest, percentage highest, right? All those places, instead of actually solving, okay, instead of actually solving for each and every value, right, you can use this concept and quickly compare the ratios. All right, so similarly, the reverse of this, okay, if you understand this, then you can easily understand, right, the reverse of this. Okay, if we have x by y is greater than 1, right, or x is to y is greater than 1, okay, then what will be the, right, think what will be the relationship? X plus k, y plus k, x minus k, y minus k, right? Think what will be the relationship, right? If the concentration is already more than 100, say something at 140%, okay, think of it like stocks, right? I'm assuming some of you do stocks these days, right? So if your stock is already 140% up, right, and then you buy some more, right, at a lower price, what happens? Your value decreases, right? Your percentage comes down, correct? Or if you know, normal, look at our orange juice example only. Say there is a concentration which is 140%, right? If you add 100% to it, right, what happens? You have something which is already at 140%, and now you are adding 100%. 140 will say you are less, correct? So what will happen? The percentage will come down, right? So x by y, if I add k and k, the value comes down. So x by y is greater than x plus k by y plus k, right? Similarly, yes. Okay, right? So again, going back to the stock example, what I was trying to say is that you already have one stock which is at 140% in your portfolio, right? Tomorrow you go on and buy, or you have another portfolio where you have 100%, a stock which is at 100%. If you merge, your overall percentage becomes less than 140, because even though this is at 140, this is at 100, when you merge, the percentage drops down, right? Somewhere between 100 and 140, right? So, right, this is what happens. So again, where is this useful? This is useful in data interpretation. Okay, this is useful in data interpretation. Okay, all right, if you understand this, let's move to the next topic, that is proportion. Now what did we understand? What is ratio? Ratio is comparison, right? What is ratio? Ratio is for comparison. Okay, so if ratio is for comparison, then what is proportion? Proportion gives us relation. Okay, now relation can be between two similar things, or relation can be between two dissimilar things. Okay, right? Let's think, when did you apply, or when do you use the word proportion, right? Directly proportional, we say two things are directly proportional, right? Think about it, right? Or two things are inversely proportional, right? Now those two things are either similar or dissimilar things, right? So the way ratio is comparison, proportion gives us relation. Okay, how does that happen? So see, a is to b is in proportion to c is to d. Okay, we say a is to b is in proportion to c is to d. Okay, this simply means a by b is c by d. Okay, this simply means a by b is c by d. Okay, now as you observe, these are four numbers, right? These are four numbers. So that is why this number, this is called fourth proportion. Okay, this number is called fourth proportion. Okay, what does that mean? That, see, there are three random values a, b, c. D is the fourth person who's coming. Say think of like a friend group. Okay, right? Think of it like a friend group. There are three friends. The fourth one comes and makes the team complete. Okay, so similarly, there are three values a, b, c. Okay, there is no relationship between them as of now. Now what happens? D comes. Okay, the value D comes, and that makes these four come under a proportion. Okay, the fourth value D comes, and that makes these three values come under a proportion. That is why D is called fourth proportion. Okay, that is why D is called fourth proportion. How do we solve this? Now you can just cross multiply. A into D is B into C, right? This is called product of extremes is equal to product of means. All right, again, you don't need to memorize all that. Just remember, ratio means division, proportion means equal to. Okay, that's all. You learn that, that is enough. Let's find the fourth proportional to this. I am assuming you guys have already done it by now. So we have 6, 15, 20, and we want a fourth number to come into this equation. Okay, a fourth number to come into this equation and make all the four come in proportion. Right? Make all the four come in proportion. So that's 6 by 15 is 20 over D. D is 20 times 15 over 6. That is 50. Okay, that is 50. You can solve. Right? Cancel by 3. Cancel. Right? 10 times 5. That's 50. Alright. So this is how we solve basic proportion. Okay, if there are four numbers, the fourth number is called fourth proportion because that is the one which is bringing all the others into a proportion. Okay. If you understand that, then you will now understand the concept of third proportion. Okay, third proportion. What will be third proportion? A third number, right? So there are already two numbers given to me, say x and y, right? Now this third number z will come, right? The third number z will come and make all of these come under a proportion. Okay, how will that happen? So we will write x is to y is in proportion to y is to z. Okay, the value of y duplicates. Okay, value of y duplicates. If you solve it, that is x over y is y over z, right? Or xz is equal to y square. All right. Now here z, as it is third number, it's called third proportion. Okay, and y, because it is the middle number, it's called mean proportion. Okay, when we do our advanced classes, we'll also learn y is also called your geometric mean. Okay, y is also called geometric mean. Alright, that will come later. Alright, so if you have three numbers, z is called the third proportion because there are already two numbers present and z is the third one bringing all three into a proportion. That is why y is called mean, z is called third proportion. Okay, moving on. Right, now as I said that in the beginning, like when we did proportion, we discussed when do we use proportion or how do we use proportion, right? So we learned the point, or we recalled the point that yes, we use it by saying directly proportional, correct, or inversely proportional, right? We use the terminologies directly proportional, or we use the terminology inversely proportional, correct? Okay. Let's focus on directly proportional as of now. What do we understand by directly proportional? If A is directly proportional to B, what does that tell you? If A increases, B increases. If A decreases, B decreases. Remember, not by the same value, not necessarily by same value. It simply means if A goes up, B goes up. The values can be different. Okay, A can go up by 2 times, B can go up only 1.5 times, but the direction will be same. Okay, A increases, B increases, A decreases, B decreases. For example, the number of questions you solve, right, as practice, or the number of topic tests or tests you take, right, and your score in the main exam. The more you do this, the more you will score there, right? So A is directly proportional to B means if A increases, B increases. Now, theoretically, how do we solve this? We write A is equal to K times B. K is just a constant. Okay, A is equal to K times B, and then you solve. Okay, or then you continue to solve there. Okay, or else, see, because we are doing proportion, right? Proportion has 4 terms, right? So what do we do? So since it is directly proportional, you can also write A1 by A2 is equal to B1 by B2. Okay, this is a much faster method because you don't need K and all. Directly write A1 by A2 is B1 by B2 and solve your question. Okay, just put values and you can directly solve your question. Okay, does that make sense? Similarly, now see, you can generalize this. If two things are directly proportional, right, it could also be that A is directly proportional to square of B. Okay, it can be said that see, A is directly proportional to square of B. No problem, just put square here. Okay, if they say square root of A is directly proportional to square of B, or A is proportional to square root of B, okay, then put square root here. Okay, the point being that if two things are directly proportional, a1 by a2 is b1 by b2, and whatever is the relationship, maintain that relationship. Okay, if you do that, you can solve the question directly. All right, continuing. Right, similarly we have inverse proportion. Okay, what does inverse proportion mean? A is inversely proportional to C. What does that tell you? That if this increases, this decreases, this decreases, this increases. Right? Think about it. The length of this video and your retention, correct? Longer the video, you drop in quickly or drop out quickly, right? Just kidding, right? The point is that if one increases, the other decreases, one decreases, the other increases. That is an inverse relationship, right? That is what is called inverse proportion. Again, if you want to solve this theoretically, you will write A is K by C. Okay, but now that you have learned that, right, now that you have learned it, what is the faster way? A1 by A2 is C2 by C1, because this relationship is inverse. So A1 by A2, right, is C1 by C2 inverse, which is C2 by C1. Again, here also, if they say A is inversely proportional to square root, put square root here. A is inversely proportional to square, put square here, right? Whatever the relationship, right, just put that and you can directly solve the question. Okay, alright, so if you understand the concept of direct and inverse proportion, right, remember one thing, we can combine these also. Okay, the way we combine ratios, right, we don't have ratios only for two variables, we have ratios for 3, 4, 5 variables. Similarly, proportion also, the relationship need not like be between only two variables. Okay, you can generalize that also into multi-variables. For example, if I know A is directly proportional to B, I know A is inversely proportional to C, and say I know A is also directly proportional to D, right? I can combine all of this, okay, and write A is proportional to B by C into D, or A is proportional to BD by C. Okay, and then I can generate my formula, right? What will be the formula to solve questions quickly? A1 by A2 is B1 by B2 into C2 by C1 into D1 by D2. Okay, point being, A does not get multiplied thrice, A remains once, but all of these can be combined and written together, right? So if A is proportional, right, if A is proportional to B, inversely proportional to C and directly proportional to D, then we get A is proportional to BD by C, right? Or you can write A1 by A2 is C2 by C1 into D1 by D2. Or if you have A is proportional to B, A is directly proportional to C, A is directly proportional to D, you can simply write A is proportional to B into C into D, right? The point is, you just read the question, identify, pick one variable, identify its relationship with multiple variables, you can concatenate all of them into one, right? And you can make your final formula to solve, right? Now this is somewhat what we use when we do those chain rule questions, or when we do those ratio proportion, time and work questions, right? When we say N1 R1 T1 by W1 C1 is N2 R2 T2 by W2 C2, right? That formula comes from here. Okay, that formula comes from here. See here, N is your number, R is rate of work, T is time, W is the work done, C is cost, right? So that formula comes from application of this, and that is why it works everywhere. Okay, we'll learn that later, right? Okay, so what do we know here? We know x is directly proportional to y, inversely proportional to z, right? X is directly proportional to y and x is inversely proportional to z, right? We can combine the two and write x is proportional to y by z, right? And formula x1 by x2 is y1 by y2 times z2 by z, right? X1 by x2 is y1 by y2 times z2 by z1, right? We know x is 6, y is 8, z is 2. So x1 is 6, y1 is 8, z1 is 2, right? What are they asking? Value of x. So they are asking x2. What is y2? Y is 12, z is 4. Right? Now I just have to solve. Right? That is 2 times, right? 3 times 3 times 2 times. Right? If you solve, x2 is 9 by 2. Right? x2 is 9 by 2. Right? Which is 4.5. Okay? x2 is 9 by 2, which is 4.5. Okay? So this is how you can concatenate proportions into one formula and solve quickly. Again, application of ratios, as I said, it quite often comes in mixtures. So we have P and Q mixtures, X and Y ratio 5 is to 3, 1 is to 1. What ratio be mixed? Final mixture, X by Y ratio 3 is to 2. Right? Now those of you who have done mixtures, we know we can use one of the two methods. You can use butterfly method, right? Or you can use the table method, right? Let's look at butterfly method first. Say I want to make the equation for x. Okay, the proportion of x. So proportion of x in the first one is 5 by 8, right? This is container P, this is container Q. Proportion of x in the second one in Q is 1 by 2, and proportion of x in the mixture is 3 by 5. Right? So I make my arrows, the butterfly, subtract the values. This is 3 by 5 minus 1 by 2. This is 5 by 8 minus 3 by 5. Right? We solve this, that is 1 by 10. We solve this, this is 1 by 40. Right? Now quantity ratio is the difference ratio. Right? So P by Q is 1 by 10 over 1 by 40, that is 4 by 1. So 4 is to 1. Alright. Same question, you can just make a table as well. Let's see what is happening. P is mixed with Q to give us the mixture. Right? Quantity, I don't know. Let that be A and B. So mixture quantity is A plus B. Now again you can pick a variable for whom you want to make the equation. Say we have taken x here, so I am taking y. Right? Y is 3 by 8, 1 by 2, and finally 2 by 5. Right? So right, again if I solve, right, that is 3 by 8 times A plus 1 by 2 times B is 2 by 5 times A plus B. Right? If I take LCM, 3A plus 4B by 8 is 2A plus 2B by 5. Cross multiply, 15A plus 20B is 16A plus 16B. 4B is equal to A by B is again 4 by 1. Right? So this is also 4 by 1. Right? Again, it's your choice. You can pick whichever method you find easier to solve. Alright, interesting question. So we have ratio of age of man and wife as 11 is to 9. After 4 years, the ratio will be 6 is to 5. Okay, let's solve this line by line. Okay, now what do we know? Whenever ratios are given, we multiply them by x to get the values. So see, ratio of age of man to wife is 11 is to 9. Right? So that means man's age is 11x, wife's age is 9x. Okay. Now what do we know? After 4 years, right? What will happen after 4 years? Right, say after 4 years. Right, what happens after 4 years? Man's age will increase by 4, wife's age will also increase by 4, right? And this ratio will become 6 over 5. Okay, this is the second line. Let's solve this. At 55x plus 20 is 54x plus 24. X is 4. right? If you solve that, you get x as 4. So what does that tell you? That man is 44 years old, wife is 36 years old. Okay, now let's move ahead. Let's read the next line. At the time of the birth of their first child, okay, so we don't know when that happened, but at that time the ratio was 9:7. Okay, what is the present age of the child? Okay, all right, let the present age of the child, right, be y years, right? Right, let the present age of child be y years. Now when was the child born? So if I am, right, if I am 35 years old today, right, I'm just telling you that's not my, may or may not be my current age, right? But if I'm 35 years old today, right, when was I born? 35 years ago. So if the child is y years old, right, what does that tell you? Right, what does that tell you? That the child was born y years ago. So y years ago the ratio was 9 is to 7, right? So y years ago age of man will be 44 minus y, age of woman will, wife will be 36 minus y, and this is 9 by 7. Again we cross multiply, 308 minus 7y is equal to 324 minus 9y, right? 2y is equal to 16, y is equal to 8, right? That means the child is 8 years old now, because the child was born 8 years ago. So today the age of child is 8 years, right? Guys, the point again to learn here is, even if it is a complex word problem, does not matter. Okay, ratio, just take the values as x and solve. Okay, try avoiding the fraction thing, that don't take x as 11 by 20, man is 11 by 20, wife is 9 by 20. Don't try to do that directly. Okay, only if total sum is mentioned, then you do that, it makes sense. Okay, because it can help there, but otherwise just take x and solve. Okay, moving on to the next one. So we have two water tanks. This cuboidal tank holds 600 liters more than spherical tank. Okay, 300 of waters has been drained from each tank. Cuboidal tank contains twice the amount of water as spherical tank. Okay, no problem. So we have a cuboidal tank and a spherical tank. Let the total capacity of cuboidal tank be C, spherical tank be S. Right? Now we know the cuboidal tank holds 600 liters more than spherical tank. Right? So if cuboidal is 600 more than spherical, this can simply be written as cuboidal minus 600, right? Cuboidal minus 600. So essentially, if you think, I don't need this S, okay, I'll just write this is C, this is C minus 600. Okay, now 300 liters of water is drained from each, so 300 goes away from each, so this will become C minus 300, this will become C minus 900, right? Cuboidal tank contains twice the amount. So this cuboidal tank contains, again, how do I solve the word problem? Cuboidal tank contains. Cuboidal tank is this. Contains means equal to. Twice means two times. Two times what? The amount of water in spherical tank. Amount of water in spherical tank is this. Again, a common mistake lot of us make. Where to multiply this to? When I say cuboidal tank is twice of spherical tank, is it C is equal to 2S or S is equal to 2C? Right? That is one place where we make a lot of mistake. So in order to avoid that mistake, just write or convert the words into your equation. Okay, it says cuboidal tank. Cuboidal tank means this. Contains means equal to. Twice means two times. Spherical tank. Spherical tank is this. So you will never make that mistake again. Alright, now we just solve this. C minus 300 is 2C minus 1800. C is equal to 1500. Right? So cuboidal tank had initially how much? 1500 liters. Okay. All right, an interesting question. So we have cost of gold bar, right? Cost of gold bar is directly proportional to the square of the weight. Okay, so C is directly proportional to weight square. Unfortunately, the gold bar broke into 4 pieces, weight in the ratio 1 is to 2 is to 4 is to 5. Okay, now the pieces were sold separately. The merchant received 1,47,000 less than the original price of the full gold bar. Okay, alright. So cost is directly proportional to weight square. So when we did direct proportion, we learned that if C is proportional to something, C can be written as KW square, right? K times W square, right? I hope that makes sense, right? Now, if this does, so cost is equal to K times W square, right? Now, this is the original price of the gold bar, right? If the original weight of the gold bar is W, then the original cost becomes KW square, right? Now what happened? This bar broke into 4 pieces. This bar has broken into 4 pieces. Now we know the total is W. So now the fraction helps. Okay. Now that we have taken the total as W, so I know this 1 is to 2 is to 4 is to 5. The total sum, right, is W. So now your fraction will help, will be faster, right? So we will say that okay, the first bar is 1 by 1 plus 2 plus 4 plus 5, right, which is essentially 1 by 12. Okay, second is 2 by 12, third is 4 by 12, fifth is 5 by 12, right? But 1 by 12 what? 1 by 12 W. This is bar 1, bar 2, bar 3, sorry, my bad, right? Bar 3 and bar 4, right? So the gold bar has been broken into 4 pieces. The weight of the first bar is 1W by 12, 2W by 12, 4W by 12 and 5W by 12. So what will be the cost of these? The cost from the relationship, right, cost will become K W square by 144, right, because it is proportional to W square, right, weight square. Here the cost, this is cost of first gold bar. Cost of second gold bar, K into 4W square by 144. Similarly, third gold bar, K into 16W square by 144. Fourth gold bar, K into 25W square by 144. Okay. Right. So these are the costs of all 4 of these. Right. Now, if I sell all of them, what is the total cost I get? Right. What is the total new cost? Right. Total new cost that I get, that is KW square by 144 plus 4KW square by 144 plus 16KW square by 144 plus 25KW square by 144. Right. If you add all of this, 1 plus 4, 5, 30, 46. 46 kW square by 144. Right, you can simplify 23 kW square by 72. Right, we get 23 kW square by 72. So the original value was kW square. The new value of all the pieces combined is kW square by 72. Okay, now what has happened? Right, where does the money come into picture? The value has decreased by 1,47,000. Makes sense, because initially it was kW square, now it is only 23 by 72 times, some fraction of it. So the value has decreased, right? So how do I find the decrease? Original price minus the new combined price is 1,47,000. Okay, take LCM and solve. Right, that is 49 kW square is equal to 1,47,000. Right, KW square is equal to 1,47,000 times 72 by 49. If you know the table, this is KW square is 260. Okay, now you just do the calculation. KW square is 216,000. Okay, what are they asking? The original price. The original price is kW square, so it is 2.16 lakhs. Okay, again the point is, since now you see 1 is to 2 is to 4 is to 5, 4 ratios are given. We could have taken 1k, 2k, 4k, 5k also. There was nothing wrong in that. Then your total would have been 12k. Okay, then your total would have been 12k. Okay, let's just do that, right? Let's just do that. So again you will see how quickly we can solve, right? Let the pieces be 1x, 2x, 4x and 5x. That means the original was 12x. Okay, the original weight or the total weight was 12x. If it is 12x, the weight, cost will become 144 kx square, right? Because weight square into k, and new cost will become, right, kx square plus 4kx square plus 16kx square plus 25kx square, right, which is 46kx square, right, which is 46kx square, right? So what is the loss? 144kx square minus 46kx square, which is 98kx square. This is equal to 1.47 lakhs, right? Cross multiply and solve. You will get kx square is 1.47 by 98, but I want the original price. Original price I will have to multiply by 144, right? 49 2s are 49 3s are, right? And you simplify, again you will get 217. Okay, this is 46, sorry, my bad. My bad calculation. Right, 49 2s are 49 3s are, right? And then you solve, you will get 2.16 lakh. Okay, so the point is, when you have total, then you can take fraction also, no problem. Okay, when you don't have total, right, when you don't have total, right, okay, it's better to take normal numbers. Moving on to the next one, looks like an interesting question. So we have decrease in speed of car is directly proportional to square of number of additional passengers. Okay, so the decrease is directly proportional to number of additional passengers whole square, right? Now it says when the car carries 2 passengers, speed is this. All right, so say, right, say the original speed, right, when the car is supposed to carry normal, maybe nobody or place, right, let the original speed be x. Okay, now what happens? The decrease, what will be the decrease? X minus whatever the value is decreasing, right? Now it says when the car carries 2 passengers, the speed is 80. So the car speed has decreased to 80. So what is the decrease, right? Now you can apply decrease is equal to k into n square, right? Or else, as I told you, you can use ratios also. So if you use the ratio method, right, then decrease number 1 by decrease number 2 is number of passenger 1 by number of passenger 2 whole square, right? Let's apply this. When the speed has become 80, what is the decrease? Original minus 80, this will be the decrease, right? Say original was 120 kilometers per hour. The speed has become 80, so it decreased by how much? It decreased by 40, right? So if the original is x, now the speed has become 80, so it decreased by how much? X minus 80. Decrease number 2 reduces to 60, so x minus 60 is equal to number of additional passengers number 1, that's 2, number of additional passengers number 2 is 3 square. Let's solve that. So we have x minus 80 over x minus 60 is 4 by 9. 9x minus 720 is 4x minus 240. 5x is 480. X is 96. Okay, so what does this tell us? This tells us that the original speed, right? The original speed is 96 kilometer per hour. Okay, that by default the car travels at 96 kilometers per hour. Okay, but remember the question isn't over here. It says what is the maximum number of passengers the car can carry before it stops moving. Okay, now for the car to stop moving, right? Now for the car to stop moving, okay, what needs to happen, right? The decrease has to be 96, the speed has to become 0, right? For the car to stop moving, what has to happen? The speed should become 0, right? That means the decrease has to be entire 96, right? So again, if I take one of these values, that the speed decreased by 16, right? In the first scenario, when there were 2 passengers, speed decreased by 16. Now for the speed to decrease completely, right, how many passengers? I don't know, right? And the decrease is equal to number of passengers square, right? Again, see, for the car to stop moving, the speed has to become 0. If the speed is becoming 0, what is the decrease in the speed? 96 minus 0, the entire 96 has decreased. This was from the question that when you had 2 members, the decrease was 96 minus 80, 16, right? So we solve this. 16 by 96 is 4 by n square. N square is 24. N is approximately 4.9, right? Or if you don't know the square root, no problem. You can simply say n is less than 5, right? Slightly less than 5, correct? Alright, now question comes, what is the maximum number? Okay, reading the question line is extremely important. What is the maximum number of passengers the car can carry before it stops moving, right? So if the car carries 5, it will stop moving for sure, right? Because my answer is coming 4.9. At 4.9 it stops. So if it carries 5, 100% it stops. But the question is maximum it can carry before it stops. So it can carry a maximum of 4 people, right? At that time it will not stop. But the moment you add the 5th person, it will stop, right? So answer should be 4. Okay. Moving on to the next one. We have Raj and Simran, right? The chocolates are in the ratio 5:7. Raj gave some chocolates to Simran. The ratio became 2:5. Minimum number of chocolates that he gave. Alright. Again, a simple ratio question. The chocolates that Raj and Simran have are 5:7. Again, total is not mentioned. So don't go for 5 by 12. Right? Raj has 5x. Simran has 7x. Okay. Raj gave some chocolates to Simran. So say he gave k. So Raj will now have 5x minus k. Simran got k more. So 7x plus k. Now the ratio becomes 2:5. So 5x minus k over 7x plus k is 2 by 5. Right? Let's simply solve this. We have 25x minus 5k is equal to 14x plus 2k. Right? We get 11x is equal to 7k. Right? We get the relationship 11x is equal to 7k. Now, if we read the question, what is it that they want? Right? That's it. Nothing can be solved. That's it. This was one statement given. We have solved that one statement. What do we have? Minimum possible number of chocolates that Raj gave Simran. So we want the value of k to be minimum. Right? We want the value of k to be minimum. Now 11 times x is 7 times k. Right? And I know x and k are integers. right? I know x and k are integers, right? If I just cross multiply, x over 7 is k over 11, right? If I just cross multiply the numbers, x over 7 is equal to k over 11. Now, since I know they are integers, k has to be divisible by 11, right? K has to be divisible by 11 because this has to become an integer because we are talking about integer chocolates, right? So k has to be divisible by 11 and the minimum such value is 11 itself. Okay, minimum such value is 11 itself. That means the minimum chocolates that Raj can give to Simran is 11, right? Alright, now just to verify this, right? 11 should be the answer, but just to verify this, see, if k is 11, right? If k is 11, you will get x as 7, right? You will get x as 7. That means Raj had 35 chocolates, Simran had 49 chocolates. Now Raj gave 11 chocolates, so Raj is left with 24, Simran will have 60. If you do 24 is to 60, that is 2 is to 5, right? 24 is to 60 is 2 is to 5, right? So k has to be 11, alright? Alright, interesting question. We have 50 workers, construction project complete in 15 days. 30 workers, same project, workers work at same rate, right? So this is that NRT thing, right? As I said, think about the relationship between variables. So what are the variables given? We have workers, right? And we have days. Okay. Now, don't just do unitary method cross multiplication. Don't just jump into it. Okay. Think. Okay. Take your time. Think. What will be the relationship, right? If there is a certain number of work to be done, if you increase the workers, what will happen to days? The days will decrease because the work will get over faster, right? And similarly, if you decrease the workers, it will take more time, right? It will take more time, right? So the relationship between worker and days is inverse proportion. Okay, workers is inversely proportional to days, right? So what do we do then? W1 by W2 is D2 by D1. Okay, and now we just plug in values. 50 over 30 is D2, we need to find. D1 is 15. 15 ones are 15 twos are 25, right? Which kind of makes sense also. If your workers decrease, time should increase. It's very similar to what we did just now. We have 480 kgs of fodder that will feed 60 cows for 20 days. How much this? How many days this? So again, if you look at the variables, we have fodder, we have cows, and we have days. Okay, let's find the relationship. You can pick any variable you want. Okay, it need not be that you have to go in this order. Say I pick cows. Okay, say I pick cows. Now, what is the relationship of cows with fodder? Provided days are fixed. If the days are fixed, right? If the days are constant, they are fixed, right? More the number of cows, more fodder you will need, right? So cows and fodder are directly proportional. Similarly, cows and days, right? What is the relationship? Now keep the fodder fixed. If the food is fixed, more cows will finish the food quickly, so the days will decrease. So cows and days are inversely proportional. We can combine and write cows, right, is proportional to fodder by days, right? Again, you can just write down the formula. C1 by C2 is F1 by F2 times D2 by D1, right? Plug in the values. C1 is 60 cows, C2 is 30 cows, F1 is 480 kg fodder, F2 is 360 kg, D2 we need to find, D1 is 20 days, right? 1s are, 2s are, 3s are, 4s are, 5, 3, 2. 2 into 3 into 5 is D2. D2 is 30 days, right? D2 is 30 days, right? Again, you can apply the NRT formula also here. That will also work directly, okay? This is again something similar to what we did just now. So he has a 50-seater tourist bus, right? The daily profit depends on number of passengers beyond a certain minimum and total kilometer traveled. So your daily profit, right, is directly proportional to number of passengers beyond a certain minimum. So the number of passengers you carry, right, minus the certain minimum, say C, okay, and total kilometers traveled, the distance you travel, right? And again, this is directly proportional, so we can just combine them and multiply, right? Now we just plug in values. See, your daily profit 1 by daily profit 2 is equal to n minus c1 by n minus, sorry, n1, the number of passengers you carry, minus the certain minimum, n2 minus the certain minimum, times d1 by d2, right? Again, you read it, understand it, convert it into proportion, right? What do we know? It says the daily profit is directly proportional to a number above the certain minimum. So whatever your number you are carrying above the certain minimum, so minus the certain minimum, whatever that difference comes, it is directly proportional to that difference and to the distance traveled, right? The more distance you travel, the more profit you are making, right? So this becomes our relationship. Now what do we know? If he carries 30 passengers, 40 kilometers, 4800. So 4800 is for 30 passengers carrying 40 kilometers, right? And 36 passengers, 50 kilometers, 9000. 9000, 36 passengers, 50 kilometers, right? Now all we have to do is solve. Cancels out. Cancels out. I don't want numbers here. 12, 18, 2, 3. Right? Now you just cross multiply. 2 times 36 minus C is 3 times 30 minus C. 72 minus 2C is equal to 90 minus 3C. C is equal to 18. Right? C is equal to 18. So what does that tell you? That the minimum number he needs to carry is 18. Okay. Again, what we did, we just applied the relationship, right? Alright guys, I hope you were able to understand the concept of ratio proportion. Remember, all the difficult questions also we can solve very easily if we understand the concept. Okay. I hope you are able to solve all of these. All the best. Hi guys, so I hope you like the way we covered this topic. Remember, this was a concept builder video wherein we covered a simple concept and tried to solve all the questions using that concept. There is an advanced video with more tricks, right, that will come as part of this series. If you have any doubts, you can post them in the comment section and we can make a solution video for that. Also, you can practice free material of the same topic from our website, okay, and take those tests.